multiply or divide both sides by a negative sign, you know what to do. It's a funny little rule. Gotta flip the inequality sign. Flip it, yeah. Times by negative. Flip it, yeah. Divide by negative. Flip it, yeah. Both sides by negative. Flip it, yeah. If you multiply or divide both sides by a positive sign, don't ever apply the rule that I described. Just keep the inequality sign. Keep it, yeah. Times by positive. Keep it, yeah. Divide by positive. Keep it, yeah. Both sides by positive. Keep it, yeah. When you time to divide by negative sign, you flip it, yeah. When you time to divide by positive sign, you keep it, yeah. When you time to divide by negative sign, you flip it, yeah. When you time to divide by positive sign, you keep it, yeah, yeah.
Well, good day, Algebra 1 students. I thought that was a good way to kind of introduce a very important rule that we got to learn here in this section, 2.3 of solving inequalities using multiplication or division, that if we are to multiply or divide by a negative sign, then we have to flip the inequality sign. But if we do multiplying and dividing by a positive, then we keep the sign the same direction. All right, so as we get into our lesson today, let's look at a little cartoon quickly here. In the bleachers, we got a coach out there on the field. Referees got some device, tap, 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 tap. It says, when I repeatedly activate the shock collar, he learns that arguing with the ump will not be tolerated. So the coach has a shock collar around his neck, and he gets shocked when he wants to go argue with the ump. Okay, let's get into our lesson. So page 40 of your notes, our core concept here, and what you kind of want to pay attention to is the red numbers here, as you can see what we're going to be doing with those numbers, and what happens to the inequality sign when we're multiplying or dividing by those particular numbers. So in this one, it is talking about that the number C, which is the number we're going to multiply by, is greater than 0, so that means it is positive. So that means we do have a positive number here. We're multiplying by a positive, and so that's what you can see is happening here. You're multiplying by positive 2, or here you're dividing by positive 2. So when you do multiplying or dividing by a positive, here, look at what we do here. We keep the sign. See, we keep it. Just like the song said, we are going to keep the sign exactly the same direction. It's less than here, it's still less than. It's greater than on this one, it's still greater than. So that's just one thing to keep in mind. When you're multiplying or dividing by a positive, you don't do anything to the inequality sign, you keep it. So let's go ahead and try a couple of those as we start here. All right, so on page 41, our first three problems here, it says solve the inequality and graph the solution. So as we've been doing already in the last couple of lessons, we are graphing our solutions here on the number line. So first of all, number 1, we get 6x is less than negative 30. So to solve it, we solve it exactly the way we would if it was an equation. If this was an equal sign, we are going to have to get the x by itself. I need to undo the 6. So that means 6 is being multiplied. We're going to undo it by dividing. So we're going to divide this by 6. So that way the 6 cancels. 6 over 6 will cancel. We got to do that to both sides, as we always know. So we divide the other side also by 6. And so on this side, we're going to get the x. So 6 divided by 6 is just 1, so 1x there. And because we're dividing by a positive, this is where we're dividing by both sides of the inequality sign by a positive, we keep the sign the same. We don't change that. It stays exactly facing the same direction. And then over here we have a negative 5, negative 3 divided by 6. So there's our solution. We want to graph this one. We want to put 0 somewhere on here. And that way we know if there's 0, then negative 5 is going to be 5 to the left of the 0. And this is where our open or closed hole is going to be at this negative 5 point. And so this one, because there is no equal to sign like there is on this one's going to be closed. This one will be open. So the one on number 1 is open, but number 2, because of the equal sign, will be a closed hole in that one. And so we have an open hole, and we're going to shade to the left. X is less than negative 5. It is always good to see that the variable is on the left. It makes it definitely easier for us to make sure we don't make a mistake when we're graphing the the shading part of this. So we're going to shade to the left of that -5. All right, go on to 2. So on number 2, we're going to have to do the same thing with 16 times f, divide by 16. So divide this by 16, that means f will be by itself, and over there also by 16. So 48 divided by 16, that is going to give us 3. When we divide that, 16 goes exactly into 43 times. But here again, you want to look and see, okay, do I flip it or keep it, just like that song was saying. This one we're multiplying by or dividing by a positive. So the number that's in front of the variable here is positive. We divide by a positive, so we keep that sign exactly facing the same direction. And here's our variable on this side. And like I said, it might be good to keep this on the other side, so you might want to flip this entire thing around. Put the f first, and then you flip the inequality sign, then put the 3. It's exactly the same thing. It's just in the order that we might be more comfortable graphing this. So if f is going first, then the inequality sign has to open towards the f, just like it's opening here. So it's opening towards the f here, 3's on the other side. The arrow is pointing to the 3, just like it is here. We're just flipping this around. So that makes us definitely helps us graph this a little bit better. So we're going to put 0 somewhere. 3 is going to be 3 to the right. And this is where our closed hole will be, because of the equal to sign down there. So it says got a closed hole, and it says f is greater than the 3, so we definitely know it's going to go this direction. And again, when you have your variable first, you can kind of look at the arrow of the inequality sign pointing in the direction that you can shade. That only works though when your variable is first. Next one, we have some fractions here, so I need to undo the 3/7 that's multiplying f. So to do that, to undo a fraction, we could do it in one step, and that would just be to multiply both sides by the denominator. That would get rid of the fractions, but then we'd still have the 3 in front of f that we'd have to divide by 3. So there is one step, that would be 2 steps. There would be one step we could do this with, and that would be to take the 3/7 and flip it upside down. It's called the reciprocal, remember? So we can multiply both sides by the reciprocal of 3/7, which would be 7/3. So I'm going to do that. I'm going to multiply here, put the parentheses around to show multiplication, 7/3, and when I do that, notice I'm crossing out the 7s and I'm crossing out the 3s. They cross cancel. That's why we can do this, because now f is by itself. But I did this to this right side. I need to do the same thing to the left side over here. Multiply the -6/7 by a 7/3. Okay, 7/3. When I do that, I'm going to cross out the 7s, and then 3 goes into 6 2 times. So 3 goes in itself once, and 3 into 6 2 times. So that leaves us with 2/1 here, which is just a 2. Or actually, I should say -2, because it is a -6/7 to begin with. Positive times negative is going to give us a negative sign. And then there's our 2. And again, what about our sign here? We don't flip it because we didn't multiply by a negative. We multiply by a positive 7/3. So that's really the key, is what are you multiplying by, or what are you dividing by? If it's positive, you keep it. So we're going to keep that inequality sign facing the same direction. Then we have our f. But I'm going to do the same thing I did up here and flip this whole thing around just to make the f going first. So the mouth has to open towards the f. So it's got to go this direction, and the arrow's got to point to the -2. And so that helps us figure that out a little bit better with the graph. So we got to put 0 on our graph. -2 is 2 to the left. So there's our -2. This one's got the inequality sign, or the equal sign down below. You know that's going to be closed in, solid hole. And we're going to shade off to the right. You can even see the arrows pointing that direction. You couldn't do that with this one. It's pointing in the wrong direction when it's in the wrong order. But if it's in the right order with the variable first, you can kind of look at that and see, well, it's going to point this way. It's f is greater than -2. So there we go. Okay, so now for the other part of this lesson, with what happens when we multiply or divide with a negative. That's what this is saying. C, the number you're multiplying or dividing by is less than 0, which means that that coefficient is negative. So the number that you're multiplying by is a negative, or one you're dividing by. Look at what's in red again. Now we have a -2 here. We're multiplying by -2, or we're dividing by -2. And look what happens to the inequality sign from the original. So the original here was less than, and now it flipped, and we flip it here. So again, that's what the song was saying. This one, we are going to flip it. Just like what's happening in this shaded part there. It's getting flipped. So there we flip it. So same thing's happening here. That started off greater than. When we divided by -2, it is now less than. We got to flip it. That's the main thing to remember when you're multiplying or dividing by negative. That really is the only difference between how to solve equations and how to solve inequalities, because everything else is pretty much just the same thing, except when you get to this very end part, if you multiply or divide by a negative to solve for that variable and get it by itself, then you have to flip the inequality sign if you're doing it with a negative. Okay, so problem number 4 and 5, you can see here that we're going to probably be using that multiplying by a negative, flipping it rule. So on number 4, we have to get rid of our -4. It's in front of the m. It's multiplying m, so we undo it by division. We're going to divide by -4. Negative over negative would make it positive, and the 4's would cancel, leave us with a positive m. You always have to have your variable being positive in your answer. So we do that to both sides. So -16 gets divided by -4, and since we are dividing by a negative, here's where we got to change the direction of the inequality. So we're going to see m, our answer is going to be m is less than or equal to +4. So our m is on the left side. This flips around. See how it flips? It was facing greater than, now it's less than. And negative over negative, here is positive. 16 divided by 4 is 4. So now we're going to graph this one. It isn't facing the right direction. We got to put 0 somewhere. 4 is going to be 4 to the right. And this one is going to have a closed hole. So you got your closed hole in there. And then we got to shade it. M is less than 4, so we're going to shade it there off to the left. And there's our answer. All right, number 5's got the fractions again. And for this one, it has x over -6. Now there's another way that this can be written that I want to show you just in case you come across it, because you will. Sometimes we don't just have the x. A lot of times we have x, like this one, m is next to the number, -4, and then m. Well, we could have a fraction and then the x, so we could write this one as -1/6 as a fraction to actually see, okay, what is the number in front of the variable? It is a -1/6. So -1/6 x is the same thing as saying that right there, x over a -6, because really, essentially, there is a 1 in front of x. So it's a 1 over -6, or that could just become -1/6. Now, we would solve both of these exactly the same way. I need to get rid of the -6 down below here. Right now, you can see it is dividing here by x. X is being divided by -6, so we have to multiply both sides by -6. That's what we would have to do here as well. We'd have to multiply both sides by like the reciprocal of 1/6, which is a -6. So we're going to multiply this side over here by -6, and that would cancel out the -6's. Those cancel out, leave me just with x on the left side. On the 1/3, we're going to multiply the 1/3 also by a -6, but 3 can cross cancel with -6, leaving -2 on the right side. So left we have x, the right we have a -2, and then we have our inequality symbol. So that's going to flip because we are multiplying by a negative number. 6 is negative that we're multiplying by, so our answer is going to say x is less than -2. So the x is on the left. The inequality sign flips. It was greater than, now it's less than, and we have -2 on the right. So if we graph this one, you can see we're going to put 0 somewhere, put -2 to the left of that one. We have an open hole here because there's no equal to sign, and x is less than, which less than is going in the negative direction. You can see the arrows pointing even in that way. Okay, so we'll pause here for a minute just to do a joke of the day. So the question is, why won't the baby oyster give up her pearl? Why won't the baby oyster give up her pearl? Well, because she's a little shellfish. Shellfish. That was a good one. Tell that to your parents. All right. Let's keep moving on. Okay, on page 42, we have these 3 more problems, 6 through 8. So we're looking at problems here now, and again, definitely more fractions in each problem. A fraction in each one does make it a little bit more complicated, but not too much, just as long as you just know what to do to undo the fraction. That's always what we're trying to do in any kind of equation or inequality. We're trying to solve for a variable and you have fractions. You want to try to undo those fractions first. So these are fairly simple ones. We'll eventually in Algebra 1 get into more difficult ones as well. So as we look at this one, 1 is less than or equal to a negative 1/4 y. So we already have a fraction here. It's being multiplied by y. So to do this one, because it's a 1/4, we can just multiply by the reciprocal, which would be a 4. 1/4 flipped upside down is 4 over 1, which is just a 4. So we also want to multiply by a negative, so our variable is positive. We're going to multiply by a negative 4 then to undo the fraction. And that is just what the denominator is. So I'm happy to do this just in one step because 1's at the top. I don't need to worry about the 1 so much. So I'm going to multiply that by negative 4, cancels out our 4's. Negative times negative will be our positive y here on the right side. Do the same thing to the left side. 1 got to get multiplied by negative 4. So that leaves us with a negative 4 and then our inequality symbol, which in this case, if you can see, is it going to flip or is it going to be kept? Well, this one we are multiplying by negative 4. So that means we definitely got to flip it. So we flip it here. So you can see you're flipping it. And now it's a greater than or equal to sign. And over here we just have our y. And there's our solution. Again, we could write this, since it's kind of in the wrong direction or wrong order, we can write this as y is less than or equal to negative 4. It's the same thing, just a nicer order to have the variable on the left. So when we graph this one, we'll put our 0, negative 4, 4 to the left of that. And then this one, you can see it's going to have an equal to, so it's going to have a closed hole. And it's less than, so it's fading off or shading off into the left direction there. Now number 7 is a little more complicated because the other side has the fraction and not the one with the variable. So normally we would probably want to just think of dividing this by negative 4. That's what we've done before. Negative 4 times x to undo this one, divide by negative 4. But the problem comes when we try to divide negative 2/3 by negative 4. It does make it a little more challenging, perhaps, when we're trying to do it this way. You might do some scratch work on the side and be able to do it just fine. But what you might want to do instead, to make this a little easier for yourself, is think of turning this 4, or this negative 4, into a fraction. And so you're multiplying. I'm going to make that a fraction by just putting a 1 underneath it. Anytime you want to make something that isn't a fraction into a fraction, just put a 1 underneath it. So that's what we're going to do here. I'm going to put a 1 underneath this and multiply now by its reciprocal, which is a negative 1/4. I got to multiply by negative because, again, I got to keep my variable positive. And then 4 over 1 flips upside down is now 1/4. So we multiply by the reciprocal. It's when you flip the fraction. That way the 4's are now being cross-canceled. You don't need to worry about the 1's. And then negative signs will multiply and give you a positive. So this whole thing now is just going to give us that x that we need by itself. So here's what we got to do. Same thing to the other side of this fraction here. It's already set up as a fraction. So when I multiply this also by negative 1/4, you can see what we're doing. So we have our negative 1/4, the 2 and 4 cross-cancel. 2 becomes a 1, 4 can cross-cancel, and that becomes a 2. So now we have a negative times negative, which is a positive number on this side. 1 and 1 times 1 is 1. 2 times 3 is 6. So we're going to get a 1/6 on this side. Our inequality sign, should we flip it? Well, we are multiplying by negative, so yes, we should flip it. So we want to flip the direction of that sign, and now we have our x on the other side. And again, it looks like facing backwards. I'm going to go and flip it around just so the x is first. And that means that the arrow is pointing to the x, just like it is here. It has to point to the x, and we got 1/6 there. So as I graph this one, again, we put 0 somewhere. 1/6 is a fraction. Each one of these is 1 unit. So this right here, if this is 0, then this is 1 right here. That's 2, that's 3, and so on. 1/6 is found right between 0 and 1, really close to 0. So you want to put a line in here. It doesn't have to be perfect, but you just so you get it kind of in there. 1/6 is close to 0. That's where 1/6 can be represented. It is going to be an open hole because there's no equal to, and it is going to be shading to the left Just like the arrow is showing us, x is less than the 1/6. Less than is that direction to the left. Now with number 8 here, we do have a fraction. It's got a 4. And so what we can do, same thing as we did up here, we could, or like this one right here I should say, multiply by the reciprocal, or even this one multiply by the reciprocal, but this one, the reciprocal, would be 5/4. So we can do that. We can multiply by the reciprocal one step. We'd be multiplying this side by negative 5/4, multiplying the -2 by a negative 5/4. You can do that. It might get a little bit complicated though. So I'm going to show you even simpler way would be to do it in 2 steps. Just start by undoing the fraction by just getting rid of the 5. Not the whole thing at once, just get rid of this 5 first, the denominator first. So that means I can multiply this by -5. So I multiply that side by -5. Actually, not even negative sign. Don't even worry about the negative yet. I mean, you can multiply by -5, but I'm showing you can just get rid of the 5 first, multiply by 5, cancel that out. Now it's just a -4x on that side, and multiply the other side by 5. It's going to give us a -10 there. So now our equation will say -4x on the left. The inequality sign, I'm going to keep that the same because I multiplied by a positive, and then -10's on the right side. And now here I can see, well, I'm going to divide by -4. To get x by itself, that's what I have to do. I just have a number over here, no fraction, so I can just divide by -4 like I'm comfortable doing. And those -4's will cancel each other out, leaving me just with the x only. And then I'm going to divide this side also by -4, but I am going to have to switch the sign here. We are flipping it because we're dividing by negative. So eventually we did. And you can know that because in front of the variable, the number in front, which is called the coefficient, is a negative number. So we know we're going to have to flip it if that number is negative. This number doesn't matter if it's positive or negative. It's the one that's in front of the variable. That will determine whether you're going to flip it or keep it. If this number is positive, you keep it. If this number is negative, you're flipping it. Alright, so now that we did this, we're going to see x over here. We're flipping this. We got to simplify this 10/4. That's going to still be a fraction though. So our answer is going to have x. Flip the inequality sign to less than or equal to, and over here we have a 5/2. It is positive. Negative over negative will leave us a positive. 2 goes into 10 5 times, 2 into 4 2 times. So the simplified fraction is 5/2. So just like this one, we have one that's not going to be a perfect number here like we're seeing. If I put 0 there, again we have 1, 2, 3 even. Where's 5/2? Well, we got to think, okay, 2 goes into 5 actually 2 times, so 1, 2, it's at least here. It's between 2 and 3, it's 2.5 actually. 5/2 is exactly 2.5, so it's right there in between. So that's where our closed hole is going to be. We're going to have a closed hole right in between at the 5/2, right between 2 and 3, shaded off to the left because it is a less than on this one, so you're going to shade to the left. Alright, we have just one more problem. That's the last word problem on this one. Okay, so our last problem here, number 9, says there are at most 36 red and blue marbles in a bag. The number of red marbles is twice the number of blue marbles. Write and solve an inequality that represents the greatest number of red marbles are in the bag. So the first 2 sentences are going to be the information we're going to use to write out this inequality here that we have to have. We are going to use the variable r, so it wants us to use the variable r for that, representing red marbles. So the first sentence is going to be one equation, the second sentence is going to be a second equation. I'm going to keep it as equations first and then translate it eventually to an inequality. So the first thing is there's 36 red and blue marbles in the bag. So the number of red marbles plus the number of blue ones is going to equal 36. So we can just say r plus b is equal to 36. That's our first sentence. So there's our first equation. Second one says the number of red marbles is twice the number of blue. So r is always going to mean equals in any kind of sentence here that we're trying to change into an equation. So r equals 2 times b. Twice means 2 times. So r equals 2 times b, 2b. Okay? Now they want us to write the inequality only with r in it, so we can't have a b in this inequality. So that means we're going to have to, make kind of an equation here in some way, which is going to be the inequality, without the b. Well, it tells us that r is actually 2b. So what we can do then is that we can substitute in this 2b here for what r is, but that would leave me with a b. So instead, I need to figure out, well, what does b equal? I already know r is equal to 2b. That's not as helpful because I can replace the r here with this 2b like I said, but that gives me an equation only with b, and I need it with r. So I need to find out, well, what is just b? So I'm going to get rid of my 2, divide by 2 here, or instead maybe multiply by the reciprocal of 2. Think of 2 as 2 over 1, the reciprocal would be 1/2. So if I multiply this by 1/2, that cancels out my 2's, gives me b by itself. Do the same thing to the other side of that r, multiply it, so now just the b by itself is equal to a 1/2 r. So now I know what I can replace the b with. I can replace it with a 1/2 r. And that's how I'm going to write out this inequality. So it's write and then solve it. So the first thing is to write it. So it starts off with writing out this equation. We're going to put the r, but instead of putting b, we're going to replace it or substitute in a 1/2 r, because b does equal that. So r plus, instead of b, we're going to put the 1/2 r now in that place. And now instead of equals, because it wants an inequality, we have to put an inequality sign. So the inequality sign is going to be one of the 4 choices that we have, either less than or greater than, or less than or equal to, or greater than or equal to. One of those 4 inequality signs, what do we use? So the clue is this little phrase right here where it says at most. That's the clue as to what sign to use. There are at most 36. So this equal sign shouldn't be an equal sign. That means the most it could be is 36. So it can't be more than 36. But it could be less than 36. So this side could be, less than 36, but it can't be more than 36. Can it be exactly 36? Yeah, at most, the most it could be is 36, so it can be 36. So we're using one of those inequality signs with an equal sign underneath it. So that kind of narrows it down now to 2. We're going to use the closed hole ones with the equal sign below. So we're going to see it's going to say a less than or equal to because it's at most. The most it could be is 36. The number 36 there goes after that. So the most that this could be less than 36. Or it could be equal to 36. It just can't be more than 36. That's why it's facing this direction, where the less than sign, the arrow is pointing this direction here. So that is our equation. There or inequality. We wrote the inequality. There's the inequality that we wrote. Now the second thing is to solve it. We should be able to solve this one. We got to combine like terms here with these two. This one's a fraction. This is not. This is like 1 plus a half or 1 1/2. You might want to think of it this way. 1 is the same thing as 2 over 2. Then we can say plus the 1/2 r is less than equal to 36. And then just add these numbers. 2 plus 1 is 3 over 2. So these two become 3 over 2r. And are less than or equal to 36. And now we need to undo the 3 over 2 by multiplying both sides by the reciprocal. So the reciprocal of 3 over 2 is 2/3. 2's cancel this way, 3's cancel that way. We're going to do the same thing over here to the 36. Multiply it by 2/3. But I'm going to make it a fraction by first putting it under 1, or over 1, I should say. And now 36 over 1 multiplied by 2/3. You can see I crossed out the 36 and the 3. 3 goes into 36 12 times. 3 goes into itself once. So now here we have a 12 times 2, which is 24, over 1 times 1, which is 1. So this is going to be r on this side. Are we going to flip it? Well, we were multiplying by a positive, so we keep it. So it's going to be r is less than or equal to 24. And that's our answer. So we wrote it here, and then we solved it here. There's our solution. All right, so that's the end of 2.3. and I'll see you on the next lesson.